All right, guys, today we're at Fast Forward Race Engines with Joe Irwin. We've been working with Fast Forward Race Engines 11 years now.
11 years, yeah.
We've got a great 2JZ engine program that we're always trying to develop and improve on. We've probably done a couple hundred engines at this point.
Yeah, we're over 200.
Yeah, so we've been very excited to get our hands on this. We've been working on it behind the scenes, working with DART directly and helping them develop this. And this is going to be the future of our 2JZ engine program. We're extremely excited, and Joe's going to give us the rundown.
Yeah, we're happy to have cores available. One of the biggest problems that we have with the program is getting enough usable cores. So hopefully this is going to solve that problem for us. This is DART's offering. This is a cast iron block. It's made with 220 Brinell hardness. So this is a hard block compared to the OEM block. The material itself is just a better material to start with. So that's a huge positive for us.
Yeah.
The OE stuff is constantly cracked. So we get them in and they're constantly broke. So this will mitigate that problem.
Yeah, we get these things in and we see cracks on the surface. We're always dealing with that and checking. We think we get a good core. When we surface them and check them, you have cracks on the surface and all kinds of other issues. And when we start to get to the power level that we're at with a lot of this new technology, new turbos are coming out, people are running harder and harder and harder.
Sure.
We're seeing the crack in the liners and the cylinders. I mean, we're seeing these issues more and more commonly now. So this is going to be really, really good. Aside from just being able to actually have cores and have blocks on the shelf, this is a huge improvement over the factory block.
Strength-wise,
yeah.
Absolutely. So like I said, this block is going to come to you here with semi-finished. So the mains are going to be finished. The deck height is going to be 2 to 5 thousandths tall. So you can machine it. You can surface it flat, get your proper deck height that you're looking for. The same thing with the bore. The bore is going to come in at an 86 millimeter bore, just undersized. So you can hone that thing to get the proper finish that you're looking for. They recommend this block to go from an 86 millimeter all the way up to 88 millimeter. We've done some testing on the factory blocks as far as the deck thickness, the cylinder wall thickness, and we'll show you what the factory thicknesses are, but this is just about double that thickness. The deck height, the thickness of the deck height is going to be around 750 thousandths thick on this, where the factory block's around 400, 430 thick.
Yep.
So substantial thickness in this area, particularly where they blow the gaskets all the time.
Yep.
This block is at 88 millimeter. We've put this block at that size so we could test it. We could run it through the extreme
true test of what it's going to be in its absolute worst form. So if you run this thing, you build it at 86 and you go to 86 and a half, 87 as you're refreshing it, or you hurt it really bad, you have to go 88. We want to know, how is this thing going to hold up in its absolute worst form in extreme conditions. We're going to put this in a car that has run 740s it's like a 3,400 pound full street car.
Full weight.
We're going to put this in that car, and we're going to try to go even faster with a newer turbo and really push it and see what it'll do. And we broke a cast block in that car.
Absolutely.
At one point.
Yeah.
A factory block. I mean, the thing just blew the side out of the cylinder wall.
Yeah, that's right.
So this will be a really good test for us. And again, this thing, when we broke that was the coolant crossover, which is the weak point of the block. This block doesn't have that. So I mean, this is again a huge improvement everywhere.
Huge improvement. This block at 88 millimeter bore has around 290 thousandths of material behind the cylinder wall. The factory OEM block that we would stop at 87 millimeter
the
bore
max that we do
would
now.
be 180, 190 thousandths thick. So this being 1 millimeter over bore has substantially more cylinder wall thickness.
Yeah. And better material.
And better material.
Yeah.
And like Victor pointed out, the coolant crossover, the factory block will show you has a coolant crossover, a steam port essentially. And we've removed all of that in this block, so no worries of cracking.
And you can even see, like, if you've ever taken apart a high horsepower 2JZ engine, you'll see the lines.
Sure.
You'll see the darkness in the cylinder wall because it's so thin there where that coolant crossover is. So not having that is definitely a great idea.
That's right. This comes with a factory head bolt hole, 11 millimeter.
Yep.
They do have the option for a 1/2 inch head stud. So if you have a head that's already machined out for 1/2 inch head studs, you could get this block in that form. They are blind holes, so no sealer on the head bolts. They don't go into water, so you don't really have to worry about anything there.
Yep.
Another neat feature is the oil provision for the cylinder head is in the back of the block. They've got that tapped. You could actually put a restrictor in that area, and that way you could limit the oil to the cylinder head.
Yep.
So if you're running into a problem where
you can increase it too over factory. The factory hole is tiny, but now
whatever you're looking to do.
Exactly.
That's right.
Yeah.
So
you have a dry sump application, you probably want to run it a little bit tighter.
That's right. Yeah.
And so on.
Yep.
Yeah.
That's right. So you've got the ability where before you'd have to do something and machine it or something like that.
We've also validated that all the OEM oil pump, oil pan, water pump, etc. all fit. So we validated all that. This one will be run with a dry sump system, but it'll work either way. Factory motor mount locations, factory everything. You know, this is something that you can buy, bring it to a good machine shop, get it put together, and just put it in your car and go. I mean, yeah, it's gonna be awesome. It's gonna change the game.
Yeah, complete bolt-in.
Yeah.
I mean, you know, if you needed a factory OEM block, you could put this in it, and it would fit right in.
And you know, when you talk about the cost, it's a really good deal. You know, if you buy one of these engines now used, you know, you can spend anywhere from $500 to $1,500 depending on the deal for just a block. You do that, you buy main caps, you buy main studs, you bring it to a machine shop, have them line bore it, line hone it, put those main caps on it. You're in the territory of what this block is going to cost you with 4-bolt mains, with main studs, and again, just a much better brand new block that's almost ready to go when you get it.
Sure. Well, let's talk about the mains on it since you kind of went there. This does come with steel billet main caps from them. It's a 4-bolt main. The factory OEM hardware, main hardware torques to 60 foot-pounds. This main hardware from 0.1 fasteners torques to 105 foot-pounds. It's substantially more torque. That'll keep the main cap seated. That'll keep them from fretting and moving around.
Yep.
Obviously, it's got a little bit more surface area having the 4 bolts.
Yep. Crank's not going to be flexing around, moving around. No need for like a 625 head stud or main stud.
Yeah.
You've got 4 of them now.
Yeah, and it's ready to go.
And they're huge.
Yeah, like, it's a big stud. Yep.
Yeah, I mean, well, no, I'm talking about the cap too.
For
the
sure.
cap is huge. You can just look at this thing and you know that it's clamping down a lot more than the factory caps.
There's no doubt. There's no doubt about that.
Yeah.
So, and when we took this block and we checked the main housing board, it was right in the middle of the spec. So that comes done. On our OEM block program, we have to install billet mains. It's 8 hours of machine work for us to bore those mains, hone those mains to size, and you completely eliminate that when going to this block.
Yeah, that's what I said. When you calculate all of that into the cost of building a 2JZ engine, this is a really, really good deal. Let's talk about these freeze plugs too.
Yeah, so these are a screw-in freeze plug. So obviously once we get this block all painted after we assemble it, we'll install the freeze plugs. So no press-in freeze plugs. These are all screw-in. All of the oil galley plugs are a screw-in threaded plug as well.
Easy to do, easy to work on, easy to mess
no
with,
leaks.
Clean. Well, and also if you take it apart to freshen it up and you need to clean it, like makes it 10 times easier. And I would imagine that's gonna have a better seal than a press-in the sense that like you blow a head gasket. We just had this happen. Blow a head gasket, you blow a freeze plug out of it. May not do that in this case.
Absolutely, yeah. It's a little bit safer option, you know, for the end user as far as you know racing is concerned.
Yeah.
And it's nice because they don't leak.
Yeah.
You know, so
another thing that we've done while the engine was here and getting ready to go together, we've confirmed fitment of a bunch of different
crank strokes.
Yeah, crank strokes, rods. We everything that we normally use, we tried to put in this engine to see. So factory 2J block, you're having to do rod stroke clearance for almost anything aside from
just about
3 liters steel rod. You're doing a 3 liter aluminum rod, you have to stroke clearance. You're doing a stroker, 3.2 or 3.4, you have to do stroke clearance. So on this deal, we found we didn't have to do that until we got to the big aluminum rods, essentially.
Correct. Yeah. So the factory 86 millimeter stroke crankshaft, steel rod fits, no problem. Aluminum rod fits, no problem. Right. When we do the hone work on these, we do put a big radius on the bottom of the cylinder so the piston doesn't rock over. So with that clearance there, no problem at all. 90 millimeter steel rod clears.
So 3.2 liter, 90 millimeter steel rod.
Clears.
Brian Crowder crankshaft that we test fit, clear, no issues.
No issues.
Okay.
94 millimeter steel rod Brian Crowder, no issues.
No issues at all.
Right?
Awesome.
Anytime that you went to the 90 millimeter or 94 with the aluminum rod, needed to be stroke clearance.
Which is not a huge deal, but it's very nice that you could buy one of these blocks, buy a Brian Crower 3/4 stroker kit, go to a machine shop and be like, hey, put this together. You don't have to stroke clearance it. You don't have to do anything. I mean, it's just one less thing to do, one less thing to worry about.
A lot less work.
Yeah, a lot less work.
We had to stroke clearance this, obviously, because we're putting an aluminum rod in it. We're going to push this engine to its limits.
Yeah. So we're going to run the same internals in this that we run in our race car that has a billet block. You've probably seen recently we went 634 at 218. This is a brand new car that we're just starting to get going on. We've had great luck with it. Engine has been solid. We're going to run the exact same internals in this engine. So it's going to have a Brian Crower 90 millimeter stroke crankshaft with a Honda rod journal, MGP rod, and a diamond piston, in this case 88 millimeter. Normally, we'll, something like this, we would probably start at 86 or 86 1/4 just to keep it as strong as possible and give you that room. So if it gets hurt, you can go up to the next size.
That's the whole point of it.
Yeah, but on this one, we're doing 88 millimeter diamond pistons, Brian Crower crankshaft, MGP rods, and we're gonna send this thing and see what it could do.
Trend pins, we got some TP1
Trend pins. We got the buttons.
That's right.
Really nice deal. This is our max effort piston. It's got the coating, it's got the buttons, it's got the good pins. I mean, we've had great success with this. This is another part of our engine program that we've worked to develop over the years. Yeah. Sure. So 11 years running, we've been using the diamonds for 8 of that maybe.
Yeah.
And we've developed this piston a lot. This is a really good piston. We run this piston, which is a shelf part number for us. We run this in our race car. It's no custom piston. It's no custom pin. This is what we run in our own program. And a lot of times you get caught up. You have to buy custom piston, you have to order this, and you have to wait weeks and weeks and weeks, and they nickel and dime you on every single feature.
Little option, yeah.
We make this standard in our HD piston. A lot of these features that you would have to pay a ton of money for are standard in our HD piston, and it's great.
A lot of other guys run that piston too, You might not know it, but a lot of other guys run it. Yeah. One of the things that we did want to bring up that we've been testing on the race car is the Diamond Claw stuff.
Yeah.
Right?
Yeah.
So we use this Diamond Claw stuff. It's a friction washer, and essentially it's to mitigate it from moving and micro welding. So
yeah, we've seen material from the flex plate to the crankshaft. We've seen it with you're fighting to get your ATI crank dampener off, or it's marring things up. You see material transfer there.
That's right.
This takes care of that. And I mean, for the money, you can't beat it.
No, I mean, I don't know how much these cranks are going for these days,
they're not cheap. I mean, it's a great product to have to replace, where you could just put this on and save that and not have that material transfer. And we've seen these things get
they destroy them.
Yeah, just hammered. Yeah. We've seen people that their flywheels come loose. We've seen people,
coming loose.
Yeah, like none of that will happen with that. It's a really cool product. We're gonna get those on our website and get those out there as well. We've been using them, kind of keeping it a little bit of a secret, but we're gonna be making those available to the public as well.
Had to put it out there.
Yeah, for sure.
Okay, so we've given you guys all the information on this block. We're gonna go ahead and get this engine assembled today and get it ready to test.
Yeah, let's do it.
Okay. All right, guys, at this point we've gotten the block in the assembly room. This block has been completely machined. So we've bored and honed this block, we've decked it, we've checked the main housing boards, we've stroke clearanced this, we validated that a rotating assembly clears all in it, final clean it, and now it's here. It's ready to assemble. Once it came in the assembly room, we've set main bearing clearances on it, we've set rod bearing clearances, we filed the rings, we validated our piston deck height. We've also made sure that our pin clearances are good on our piston and our wrist pin.
Thrust, the whole
thrust, everything, right? So at this point, we're just going to show you guys some of the assembly of it and go from there.
All right, so let's grab these oil squirters. We'll get those in there. Put a little goop on those, a little Loctite on them.
A little assembly lube on the O-ring.
Enough or more?
Yeah, that's perfect.
I guess you could run these with the oil squirter if you chose to, right?
You can. This will all fit.
So you could run these blocks with the factory oil squirter.
That's right.
Or you can run it with the block offs, which are included. We run block offs in our engine program. Well, I guess you want to give the people some more secrets, Joe. Let them know.
Well, anytime you're going to run a lot of cylinder pressure, you want to make sure that you have enough not only volume of oil, but good oil that's not aerated. And you want to make sure that you have enough oil pressure. One of the problems with running the oil squirters is there's a hemorrhage there. The factory oil squirters were designed to be used with a piston that can't sustain the heat. So they need to cool the piston off. We're using aftermarket stuff, you know, a forged piston in these things. There's no need for an oil squirter. No need to keep the piston cool.
What if you were building one of these for like a circuit racing application like the Forge Line car we just tuned? Would you run them in that application?
No, I wouldn't run them in anything like that. Like I said,
essentially anything with a good forged piston doesn't need that.
That's
and
right.
Our piston is designed and has the provisions that, you know, we're comfortable not running the squirters essentially.
Sure.
Yeah, and we've not ever seen a single issue from not running the squirters.
Never.
Ever. Yeah. If anything, we've only seen benefits. These things make a ton of oil pressure that way, and they like it.
Yeah, there's no real benefit. Now, if you had to run the factory piston, absolutely.
Yeah.
Right? You know?
But if you have to run the factory piston,
this isn't
really what we're talking about right now.
Nope. So we do put a little Loctite on the threads of these bolts just so we don't have any problems with them coming loose. Little oil on the O-ring so you don't tear the O-ring going in.
Did you put Loctite on?
I did.
Okay, yeah, I did. Okay. I was about to open it and do it. So now, we got this beautiful Brian Crower crankshaft. So 90 mil stroke Honda rod journal.
That's right.
Billet crank with, we already put the oil pump drive gear from Brian Crower on there.
Yep.
You got in there.
Got to install the gear.
Yep.
We've balanced this crankshaft.
Yep. So this is ready for the engine. Drop this bad boy in there.
Yep. Final cleaned it. We use Bradenton for all of our assembly lube.
And when customers always ask us, what oil do you suggest? This is what we use from the assembly to the first fire up and what we run down the track. We run Bradenton in all of our stuff. We've had great success with it. When you're buying an engine from us, if you can't find it, you need it, we'll send you a case, whatever the case, but this is what we run in all of our cars.
Got a good cleaning characteristic so it doesn't run off of the bearings.
Which is good too, because you know sometimes people will buy these engines from us and it might sit at their shop or in their garage for a little bit of time, and we feel good knowing that it's got the good stuff on it already.
For sure.
Yeah.
And like we said, this engine here, this has hours and hours of time in the assembly room already.
Yeah.
It looks fast what we're doing here, right?
Yeah.
But that's because, you know, we've taken all the time to get to this point.
Yeah.
So we've installed our block side thrust bearings there. The crankshaft's been final cleaned. We've ran brushes through all of the oil holes and final cleaned the crankshaft so it's ready to go in.
Got a big puppy?
I got it.
All right.
Okay.
Beautiful. You want me to goop these up?
Yeah, let's go.
What do you want me to do?
There you go,
I
Bob.
can't just stand there.
That's right.
I'm not that way.
So we want to make sure our thrusts are nice and flat, ready to go. Got good movement. These main caps have an arrow on them as well. You always want the arrow facing forward. something to note as well with this block is the mains are doweled. That dowel pin is there to locate these caps forward to back and to locate them correct every single time. We'll put our tabbed thrust bearing now.
Pretty cool feature. They have the bolt hole in the caps to remove them properly.
Sure. Yeah, it's threaded. That is a metric thread. You could put a slide hammer in here to remove the caps. Yep. It's a nice feature. Very nice feature. Now all of the main hardware on this block is from Point One fasteners. Point One has a different assembly lube that comes with this stuff, so you're going to want to use that as well. You can see all of the threads have that assembly lube on it. Man, Vic, when's the last time you put an engine together with me?
With you?
Yeah.
I don't know. I don't have the answer to that question.
Now we're going to get this thing 75. Alright, into the final torque, 105 foot-pounds, which is considerably higher than the factory. Mark that. Okay, now these outer bolts are going to go to 55 foot-pounds. Five down. Perfect. Okay. At this point, we've got the crankshaft in it. We've got the thrust check on it. We're going to go ahead and roll it up, and we'll get it ready to put the rods and pistons in it. One of the things that we haven't showed you guys in a while is the crankshaft sockets. you guys have these in stock at Induction.
My life secrets.
I'm giving them out.
It is out here now.
Boom. Right. Make sure you get them.
Look how nice that thing spins.
Makes doing this. Yeah, oh yeah, the crankshaft's beautiful. Yeah. Makes doing this a lot easier. Put a little bit of oil on the skirts. Make sure our rings are all apart. I know it seems like we're going through this really fast. Like I said, this thing, you know, this engine's been in the assembly room for hours and hours and has all of this measurements all done already. But take your time, no need to rush. All right, rod torque 65 foot-pounds.
Alright guys, so spent some time with Joe today, got this thing all dolled up and ready to go. We'll paint it, put some freeze plugs in it, get a cylinder head on it, and get it back to the shop, get it in the car.
That's right, we'll go test this thing, we'll validate it,
yep.
We'll take it back out,
yep.
Make sure everything looks good.
Yep, make sure everything looks good.
You know?
We have a lot of faith in this thing, it looks great. As you can tell from this video, we went over all the details. Great piece, I mean, we're excited to use it. I think it's going to have great results, and we'll come back with more of that in the next video.
That's right. Thanks for watching.